Welcome back to Geometry, Chapter 8, Section 6 in this book. But you don't have to have this book to learn this idea. If you're just on YouTube and found this video, you can learn about proportions and similar triangles. Now, what's a similar triangle? They have different sizes, but the angles are all the same, which makes them have similar shapes. The sides are proportional, the angles are the same. All right? So I actually told you this. It was sort of a spoiler. You know, I don't like trailers because they spoil the movie. They tell too much. So I don't watch them. Ever since Ratatouille. Ratatouille told too much. I felt like I'd already seen the whole movie. And that movie about those blue parrots, Rio, same thing. So I sort of gave y'all a spoiler because I told you that if you have a triangle and the lines are parallel, a line going across it, it cuts the big triangle, it makes a smaller triangle that is similar. I already told you that. Well, now we got to the official thing in the book. Okay, so if you've got a triangle with parallel lines, then A is to C as B is to D, and vice versa, meaning if A is to C as B is to D, then those lines are parallel. So the converse is also true. So here's an example problem. We have 4 is this section, 8 is that section. I know it's drawn terrible, but you can look in the book and see the good drawing. This one's X and that one's 12. So we could say 4 is to 8 as X is to 12. We cross multiply. 4 times 12 is 48 equals 8x. You divide both sides by 8 and x equals 6 because 6 times 8 is 48. The 6 ones are all cheers. 6 times 4 is 24. 6 times 6 is 36. Anyway, they're fun. Okay, so now then, here I've got these proportions. Are the triangles similar? Are the lines parallel? Because those go together. So I've got, this is 56, that's 48, that's 21, that's 16. And notice they turned it on its side. A lot of times they'll do that like on the SAT, the ACT, to try to trick you. So they turned it on its side. So I can say 56 is to 21 as, is it the same as 48 to 16? Well, if you reduce 56 over 21, it's 8/3. And if you reduce 48 over 16, it's 3. So are they similar? Are the lines parallel? No. Now, your calculator will do this fraction reduction for you. If you've got this TI-84, it could not be a cool pink one or fuchsia, but you divide 56 by 21 and it'll give you a weird decimal. Then hit this button that says math, which is ironic because aren't they all math? And then hit enter 2 times, enter, and it will give you the fraction, the reduced fraction. So that's sort of a nice little thing, and I wrote it over here too, because you could do math, enter, and then you get, it'll make it a reduced fraction for you. It might be a mixed number, but at least it's reduced. All right, another thing is this works even if there's 3 lines. Ooh, and even if you take off the top of the triangle. If these go long enough, do you see how they'll hit and make a triangle? So even if you take off the top of the triangle, and even if it's 3 lines, it's still true. It's divided proportionately. So it turns out that A is to C as B is to D. It divides it into proportional sections as long as these are parallel. So, and then another rule is, if you have a triangle and an angle is bisected, it divides the other side into proportional sections. So AD is to DB as CA is to CB. And you can make a proportion. They'll give you 3 of the 4. You cross multiply and figure out the one you don't know. All right, so we are given this shape. It's the situation where, you know, we just didn't finish off the triangle. And we are told that these angles are the same. Well, we know that rule, that if the angles are the same, we know these are parallel lines because of not alternate interior angles, corresponding angles. Remember that when we did the lines being cut by a transversal? So we know that these are parallel and that we're in the chop off the top of the triangle scenario. We're told that this section's 9, this one's 15, this one's 11, and this one's x, and we need to solve for x. So we say 9 is to 15 as 11 is to x. Cross multiply, 9 times x is 9x. 15 times 11 is 165. 165 divided by 9 is 18 1/3. Okay, so here's another one. This one is this scenario. It's bisected. I know it doesn't look like it, but just use your SpongeBob imagination. Okay, so but we're going to pretend it's bisected nicely. So we know x is to y as 9 is to 15. There's a lot of different relationships here that we can set it up. We're not told what x or y is, but we know the whole thing is 14. We know this one's 9 and this is 15. So I set it up, and the book did it slightly different. I set it up 15 is to 14 minus x, because 14 minus x is y, as 9 is to x, okay? And then I cross multiplied, did the distributive property, gathered up my terms, 2 on each side, woo! And then, well, I found out that x is 5.25. The book set it up, instead of solving for this one, they solved for that one. So their answer is 8.75, but really all I had to do was do my answer, 14 minus my answer, and get the other answer. I defined x as the other part of it, but you can do it that way too. So take a look at it, make sure it makes sense to you. I just solved for here, and they solved for there first, which shows you there's a lot of relationships here you can solve for. So here's another one. There's a triangle, and it's got 2 things that are missing. This little section and the bottom of this one. And so a lot of times they'll do this where you have to solve for one before you get the other, or you just have to do it twice. You have to not get confused and quit in the middle of the problem. So I did 9 is to 13 as 37.5 minus x is to x. I set those up, cross multiplied, used the distributive property, gathered up my terms, and ended up with x equals 22.5. And then I did the bottoms, and I said 9 is to 7.5 as 9 plus 13.5 is to y. So that's 9y equals 22.5 times 7.5 to do the cross multiplying. And then divide both sides by 9, and y is 18.75. So this gives you a great opportunity to practice all that solving for x, cross multiplying that you learned in Algebra 1 and maybe you're a little fuzzy with. This is a great opportunity for you to do it. Do your homework. Remember, only do the odds after every problem. Check your answer in the back of the book. And make sure you're doing it right. And if you didn't do it right, figure out what you did wrong. MacGyver it. Go from the answer back to the problem and figure it out. Alright? Come back for the last section of Chapter 8, Dilations. Math is great.